Welcome back to Pre-Calculus. As I did say, we were going to move on from trig. I want to take a look at some other concepts around numbers, trying to get a little bit more into the real world, some different things that we do need to deal with. Some of the things you're going to see today, if you're in physics, you'll recognize from physics. We're going to take a look at vectors and be able to determine equal, opposite, parallel vectors, and as well as be able to add and subtract vectors. So a vector is a number that has a direction. So most of the times you're dealing with numbers, you're dealing with just the number, the quantity. There's a lot of things listed here that are scalar quantities, but many other things, the direction that you're going is important. So all of these things that are listed under vector qualities, those are things that we deal with in physics, in the real world. We're going to put them in standard position, just like we've put angles for a little while. We will also get to compass directions. And so we're going off the positive x-axis, positive being counterclockwise, and we give a vector a magnitude, which is the number, and a direction, which is going to be our angle. For a vector, we're going to have a little arrow that's kind of like a one-sided arrow above our letter. We can have a vector that's 0, magnitude, 0, direction, could actually be any direction because it doesn't go in any direction. Kind of like how 0 is not positive or negative. Same type of thing with a 0 vector. We're going to use rulers and protractors to measure angles. I realize not everybody's going to have these at home, so if you kind of sketch what the direction is, give me an idea that you understand what's going on, we'll work with that. We can have vectors that are equal. They have exactly the same magnitude and direction. We can have vectors that are opposite. The magnitude is the same, only the direction is 180 degrees off our original direction because we are dealing with angles right now in degrees. So we can have them being different magnitudes, but they're still going in the same direction. We can have different directions, but the same magnitude. Those aren't equal either. They have to have both in order to be equal. Same magnitude and same direction. The main way that I think of adding and subtracting vectors is thinking about airplanes and flying. Because when you're flying, you tend to fly in a straight line. You're going to fly to a certain town, get back in the plane, fly to a different town, and you're going to fly straight as the crow flies. So these are the two different vectors that you're flying. The blue vector has its own magnitude and direction, and the red vector has its own magnitude and direction. Well, if I kept those both from the exact same starting point at the origin, and then I finished off the parallelogram in either direction, so I could go blue, and then this guy is parallel to this one, same magnitude. I'm going to land here. That would be addition. I could have also gone red first and then blue, and I'm going to land in the same direction. Addition doesn't matter what order we do things in. So in this way, this is called the triangular method. So what I do is I pick one of the vectors I'm going to use. I'm going to start by drawing it out. So this one is 10 units at 28 degrees. Then I have in the little black lines here a new XY axis so that I have a starting point for my 8 centimeters at 75 degrees. And I would measure my 75 degrees here just like I measured my 28 degrees here. The combined vector is called the resultant vector. If you are subtracting a vector, what's going to change is your direction is going to become 180 degrees off of where it was. Now the other way we can add and subtract vectors is by doing the trigonometry. We're just going to be dealing with kind of sines and cosines because when we set up our unit circle, so if our x was our cosine and our y is our sine, remember the unit circle and how we put in x and y here, cosine and sine, we can deal with our little angle here for x. 8 times the cosine of 25 is going to be the part of the angle that is in the x direction, and 8 sine of 25 is how much is in the y direction. Then for our second angle, our second vector, vector b, we have a 4 centimeter and 102 degrees, so for cosine 102 and for sine of 102. This is going to give us our x distance, our y distance, and in order to get the actual magnitude, we want to get back to the line that is at an angle. We're going to use the Pythagorean theorem, square root of x squared plus y squared. And for the direction, we need to come up with our final angle, and that's going to come from tangent. And we're going to do tan negative 1 of y over x. So these are the steps that we take. So let's take a look at example. We have 2 vectors that we would like to add. When we do that, we need a couple things. We need to find x and y. Here are the equations for x and y. Do make sure your calculator got put back to degrees. We've been working in radians for a bit. And x is 4.55 and y is 1.31. We're not done. Our next steps are to find the magnitude and direction. The equations are Pythagorean theorem and the inverse of tangent. We get a magnitude of 4.73 and a direction of 16 degrees. So the resultant vector is 4.73, 16 degrees. We can multiply any vector by a scalar, and that scalar does not change the angle. The direction stays the same. The only thing that gets multiplied is the magnitude. When we subtract a vector, the only thing that changes is the direction, and it changes by exactly 180 degrees. So you can add or subtract 180 degrees depending on what number you have. Usually you're going to be subtracting 180, but both of them will get you to the other end of the circle, and the magnitude does not change. Let's take a look at a subtraction problem. We want to find vector A minus vector B. These are our vectors. The very first step we need to take, we can't just put a minus sign in the problem. We need to find negative B vector, and that is going to end up being changing the angle 180 degrees. So in this case we added 180 so that we got a positive angle. Now we are ready to find x and y. We set up the same setup. Magnitude times the cosine of the angle plus magnitude times the cosine of the other angle. Do the same for sine. Get those values. If they are negatives, we do keep track of that. Do some calculations to find the magnitude. Now, yeah, I have my negative signs here, but I'll be honest, when I plug this into a calculator, I don't put the negative sign because I know it's going to be positive. It's easier to type in without that. And tangent, it's very important that you keep track of your positives and negatives here. This can make a big difference, but the calculator has a little bit of a problem with this. When the calculator gives me magnitude, I'm good, but the direction that it tells me is 5 degrees. And if I take a look at a sketch of vector A, vector B, and I'm subtracting vector B, so it's coming this direction instead of this direction, my resulting vector is in green, and that's not at 5 degrees. 5 degrees was this direction right here, and I am going the opposite direction of that. So I do need to take a look at these and make sure I know which direction I'm going. Because of the limits of the calculators, you've got to sketch it out and think about it. The resulting vector is 8.6 and 185 degrees. And I should have put in centimeters on that. We should have units on those at all times. Okay, so you're going to be taking a look at sketching some vectors, doing some addition and subtraction of vectors. As you have questions, please make sure you email or PM me. And have a good day.